Alright, well, welcome back. It's a beautiful November day in South Jersey. I picked up this Onan generator this past week, and I think in this video we're going to get it running. We'll get it producing power and hook it up to the load bank and see what kind of life this thing has left in it. It was built in October 1954. Originally, well, the story is that, sorry about that. The story is that it came out of a fire truck, so that's really all I know about it. I bought it over in Delaware County, Pennsylvania. Apparently it was a local fire company that owned it. So let's get a closer look at this thing and see what we're up against. Okay, well, here's a close-up of the nameplate. You can see it's 3,500 watts, 120 volt, single phase, 115 volt. That's how they rate it. It's a 305CK. Serial number puts it as October of 1954. It's in pretty decent shape. At least the sheet metal is up top here. It's got that kind of neat scalloped look to it. This whole thing kind of has an Art Deco look between the base and the shrouding and everything. Even has what looks like an original muffler on it. Let me pop the covers off and we'll take a look inside the control box and under the engine shroud. Okay, removing the engine shroud is simple. A couple clips here. Lift off of here. Still in shot. I think I moved the table there. Yeah. And the control panel shroud, similar, a couple thumb screws, comes off. Oh, came with a complimentary mouse nest. Nice. Looks pretty original under there. Let's see. Got our fuel pump down there, sediment bowl, carburetor. Got the points box back here. The governor is internal to the engine. Got some linkage there and a vacuum booster. Pretty standard Onan stuff. Who makes that carburetor? Oh, it's a Marvel. Okay. Yeah. Air filter box down here. Let's take a look in the control box. Let me give you a close-up shot of here. Start stop buttons, charging amp meter, and a selector switch for either hand start, which would be wrap a rope around the sheave here on the flywheel, or electric start. Control box is actually pretty original. It's nice to find them like this. It looks like somebody's replaced the original starter solenoid with kind of a generic, probably apply positive to pick the coil up or pick the contacts up. So this here probably went to a remote starter button. So they're just going from the positive post probably out to their button and then back to the post on the coil here. They're also sending positive somewhere else. Oops, sorry about that. I don't know what that could be. We'll have to dig in and find out. Oops. Probably a voltage adjust resistor there. Maybe a charging resistor here. Not sure what these are. So I'll see if I can pull up a diagram for this and give you a glimpse of that. Let's get it wheeled inside and blow it off, get that mouse nest out of there, and start working on it. Okay, well, I've got the front blower housing or air shroud off the engine. Can't take it off completely because I got this oil pressure line from the engine feeding the pressure gauge here. So I got all the mouse nest blown out of it. I also popped the cover of the control, or I should say popped the control box up so I can take a look underneath. So let me talk a little bit more about this unit. It's a pretty interesting design, and it's a bit complicated. Well, I should say it's a bit more complicated than I initially thought. At least the control system. So the ignition is magneto. I thought it was battery and coil originally, but there is a flywheel magneto coil under there. Magnets on the wheel, on the flywheel itself. So we got the lead coming out. This is acting as the primary, running up to the points box here, points and condenser. And there's another lead that comes off of this terminal and runs up to the primaries of these two ignition coils. These are, according to the wiring diagram, these are just 6-volt automotive style ignition coils. They're Autolite brand, one for each cylinder. The primaries of these coils are in series, and that's tied to the output of the coil under here, under the flywheel, which they all terminate together at the points box. The secondaries obviously come out the spark plug wire to the individual plugs. And then the only other lead that ties on here is the stop wire, which runs back to the stop relay on the control box. That would be this little guy right here. Initially, I didn't know where that was. I was assuming it was going to be on the top here with all the rest of the equipment, but nope, just hiding under here. I'll spray those contacts down, but I imagine it's just fine. Just a little dirty. Couple capacitors. Well, there's one right there, filter capacitor. Let's see what that's doing. Wire coming down from there. Where's that going? Kind of hard to see down there. Anyway. I managed to snap off one of the spark plug terminals there, trying to take it off. These wires are awful stiff, and they are shielded. So I imagine this unit would have had the steel kind of cover caps that go over the spark plugs originally, just for radio interference suppression. This wire is also shielded, as is the stop wire going back to the stop relay, all shielded. Pretty good build quality. What you'd expect from a unit this age. Unfortunately, I'm missing the electric choke. Not really a solenoid, but heater element. So that whole assembly, I think, would have clamped onto the carburetor body here. This, and then this little bracket was added to give a manual choke cable. So I'll try to track one of those things down if this little unit proves to be worth it. So I'm not sure what I'm going to do next. Probably clean up the ignition system, maybe replace these wires, and put the blower housing back on. Okay, well, I've unstrapped one of the coils from the blower housing. Just take a better look at it. Let me zoom in here. Genuine Autolite product there, made in the United States. So I figured, well, while it's out, let me save myself a little bit of frustration if we do have some ignition system troubles. And we'll check out the primary and the secondary side of this coil while we're here. So I've cleaned the tops of these two terminals. This one's labeled positive and this one's labeled negative. So through the primary, 1.8 ohms. I got, and my leads have about 0.6, 0.5, so maybe only 1 ohm through that primary coil. It seems just fine. And then from the secondary to ground, 4.8K. It seems just fine. Hopefully that coil's good. We'll see how it operates after it gets hot, after we put some load on the engine and heat it up a little bit. Although, thinking about it, these coils probably stay pretty cool being under this air shroud. There's constantly air from the flywheel blowing past them, so even if these things had maybe not the most the greatest secondary windings, they might still survive plenty long because they're always kept fairly cool with the engine's cooling air. So here's a look at the original spark plug wire. This end went to the coil lead out tower, and then they grounded the shielding. So yeah, I think I'm just going to put a piece of the Packard 440 wire to replace this. Won't have any shielding on it, but if I ever come across two of the caps for the spark plugs, I'll actually replace the new wire with the shielded wire. So alright, let's proceed. Enough yapping. Okay, well here's our two new plug wires. They came out pretty nice. Get them installed and we'll get that blower housing back on. Okay, one last thing before we get this control box and blower housing put back on. Now, we got two electrolytic capacitors here. One's mounted here, and the other one was mounted right here, this one. So these are filter capacitors or condensers. Just to let's see, this one is connected to the DC side, the positive going in to the battery, and then this one was connected to the ungrounded output from the generator. So I wanted to pull both of these off because I've had, working on old generators, I've had a lot of surprises with these old filter capacitors. They'll just randomly pop, and they make a big mess and a smoke cloud, and it's pretty unpleasant to clean up. So I pretty much just remove these on any old generator I work on, and I don't even really replace them because, you know, they're not necessary in this day, at least for what I'm using these things for noise filtering. But in pulling off that one capacitor, looking at the ungrounded output terminal here, you can see that there was definitely some heat on this wire and this terminal, and on the terminal that was also landed here as well. So just by looking at the conductor and the jacket, the insulation, you can tell that got hot. So high resistance connection here. Either that or they were severely overloading the generator. So what I'm going to do is cut this terminal off, strip the wire back a ways, and crimp a new terminal on. I've had these terminals sitting around a while. I've been waiting for a use for them. I don't have very many of them. They're pretty high quality. They're Thomas & Betts, and they even say Navy on them. I'm not sure what that indicates. I don't know if they were ordered by the government or what, but they are a nice heavy-duty terminal. They even have serrations in the barrel there to grip the conductor. So we're going to clamp that on there and put some heat shrink on it, maybe even flow a little bit of solder over it, and put this control box back on. Okay, I know you're probably saying to yourself, shut the hell up and get the job done, but take a look at the nut and the washer there from that terminal. The pitting, definitely evidence of arcing. So, good thing we found that. Okay, well that's another job done. Nice secure connection there. Now, before I put this back on, again, I almost forgot about the points. So I've got the points box pretty much gutted. Got the plunger here, which is loose, nice and free. And a little rubber boot, which is nice and supple. So that survived. Got the points here, they're in pretty good shape. Gave the contacts a little file. Now the condenser, Onan part, of course. Now it says 0.3 microfarad there. According to my my meter, this is way out. It's like it says supposed to be 0.3 microfarad. It's like 1.6 microfarad. So that's, I don't know, I don't think I've ever seen one raising capacitance, but we're not going to bother using that. I've got these here, plenty of these in stock. These are 0.22 microfarad, and they carry a higher voltage rating. These are 400 volt rated. This is only 300 volt rated. So I use these on almost all like small engine related ignition systems. I think I got about 100 of them. So I'm going to put one of these in there and put the points back on. Alright, well, while I'm assembling the points here, I just thought I'd show you this handy tool for starting these little screws that are kind of difficult to access back there, especially that one down there, and there's one up here that hold the backing plate for the points down. So here it is. It's an old tool, and I haven't ever seen another one. It's a snap-on. It's an SS3. Now, let me put you on the tripod so I can show you how this little thing works. Sorry about that shot there. Okay, let me get you here. It's upside down, isn't it? So it's just made for these little guys here, these little screws. So the tool's got a spring in it. So you take it and you line it up and you press down, and it holds the screw there. And what it's doing is, you see the split blade there with the one in the center. When you press down, that pops up, and it goes on an angle not quite perpendicular to the two outer blades, but enough to lock the screw in place. And then as you tighten the screw, it automatically disengages from it. So real handy for starting little screws like that, especially in a points box like that. Alright, well, I wanted to say a couple quick words about starter solenoids and these old Onans here. So when I initially took the cover off of this unit, control box cover, hope I'm not blocking the light too bad here, this is what the previous operator had installed for a starter solenoid. Apparently, the original must have failed some point long ago. So this style is pretty simple. This is, I really probably shouldn't be speaking about this, but I don't know the nomenclature for starter solenoids. I don't know what exactly you call it, but I would call this an internally grounded starter solenoid for this reason here. So you have your two main posts here. This is where the main current, the load you're trying to switch is flowing between this post and this post. So this post here is for the coil that would close the contact and allow the current to flow through the starter solenoid. So this style, one leg of the coil terminates at this post, and the other leg terminates to the mounting bracket of the starter solenoid, which would go to ground. So you would apply 12 volts to this terminal to pick the starter solenoid up. So let's check that out here. So we should have some continuity between here and the bracket. Should. Oh. .8 ohms or so. Not getting a very good connection here. But anyway, that there is a path to ground from this post to this post. There is no continuity from this post to either of the main terminals. Okay, so on a lot of the old Onans, this one included, the controls are they work on a apply ground basis, not apply positive. So when you push the start button is essentially taking the starter solenoid's signal and pulling it to ground. So originally this unit would have had a solenoid which looked similar to this with only a single terminal, but within the solenoid itself there would have been a connection from the battery positive post to one leg of the the solenoid's coil, and then the other terminal, the small terminal, when you would take this and tie it to ground, that would cause current to flow in the solenoid coil, pick the contact up, and then you'd have a circuit through the main posts. So I'm going to use this coil here. I keep these in stock. I call these isolated coil solenoids. So we still have no continuity between either of the posts, either of these small posts and the large posts. And we also don't have any continuity between the small posts and ground. We do have continuity between the small posts though. 16 ohms or so. So what I'm going to do is make an external jumper from one post to battery positive, and that will allow me to apply ground to the other post to complete the circuit for the solenoid coil and close the main contact. So I like these because you can pretty much make them work however you like, as long as you don't have a setup like an automotive setup where sometimes they've got a second post here. See how this one is labeled S for start, oops, sorry, and I for ignition, where this one ties directly to the load, or I don't even know, the load or the line, to give your coil of your engine full voltage when you're cranking. So not really good for automotive applications, maybe some, but definitely good for kind of industrial equipment and old Onan generators. So this is a Coal-Hearst part number there. Keep a couple of these on hand, they're really handy. Alright, let's get back to work. Okay, where are we now? Got our new starter solenoid installed. I've checked spark by spinning the engine over by hand. We got good spark at both cylinders. I've pulled the DC brushes off the commutator already. Gave the brushes a little buffing. They're all nice and free in their holders. Also gave the DC commutator a little bit of a buffing. And I pulled the 4 AC brushes out off the slip rings. They need a little cleaning, a little buff. And same with the rings themselves. Now the slip rings are pretty difficult to get to. They're hidden. You can see one right down there. There's another one over there. They're a bit difficult to get at. So what I was hoping to do was, with the spark plugs out, use the electric start function and turn the engine over while having like a little piece of wood with a piece of Scotch-Brite on it, riding on the slip rings one at a time, to just give them a little buff. So connected a battery, got a nice heavy battery here, battery cable's all hooked up, hit the start button, nothing happened. So I start probing around. I got 12 volts where it needs to be, 12 volts at the start button, but no continuity through the start button to ground. So I pulled a little button apart. You can see the two terminals there. One is shiny and new, the other one is heavily tarnished and corroded. Similarly, inside the button, this is kind of delicate work here, there's a little copper disc which actually makes the connection, and that tarnished point right there, it was lining up directly with the tarnished contact. So I don't know, maybe a little buffing of Scotch-Brite on that and the contact, and I'll see if I can manage to get this button back together, and we'll see if it starts. Interestingly enough, when I found out this wasn't making continuity through it, I checked the stop button. The stop button has no continuity through it either. So that's interesting, but well, that'll be the next thing to pull apart. So stay tuned. Okay, well that worked like a charm. Got two nice clean slip rings, good clean commutator. Gotta put the brushes back in their holders, and we got two functioning buttons here, start and stop, so that's good. You know, I'll set those brushes back in, and we'll come over and take a look at this oil pressure gauge. You know, I was thinking about pulling this out, and I still may replace that line at some point, probably a good move. But I really like the lettering and I guess the script, or the font you would call it, on this gauge. And I would bet my money that that gauge still works, and it's probably fairly accurate. So I think that's going to stay there. while we're here, and I got a camera on, let's take a look at the oil in this thing. It's full. It smells like old gas engine oil. It doesn't smell heavily of fuel, but definitely in the gasoline engine. Yeah, a little sludgy at the bottom down there. Yeah, a little sludgy there. Not the worst I've seen, that's for sure. There's some sludge there. Yeah, I think we're gonna run it. Start it up, warm it up, then we can drain the oil out. But that oil smells fine. Enough to run it, warm it up. Alright, let's keep going. Alright, let's take a look at that oil pressure. See what we get. This is just cranking with the spark plugs removed. That's pretty good. Almost 20 pounds at cranking speed. Well, a little higher than cranking speed because we got no spark plugs in. So I think we're ready to put those spark plugs in and take a look at the carburetor. Make sure that's ready. Alright, well, we got the top popped off the carburetor here and the sediment bowl dropped. Interior looks fine. The inlet needle seat looks fine. Almost looks new. Float. Inlet needle. Sorry about this. Bad angle here. Looks nice. Gasket even came out in one piece. I think I'm going to go ahead and make a new gasket just because this one is pretty simple to make and this one's really thin and brittle. Taking a look in the bowl here. Pretty clean. Got a little sediment down at the bottom there, but no corrosion, thank goodness. So I'm not even going to bother pulling the bowl off. We'll see how it runs. And if we got to go further and pull the bowl and the main mixture needle and the idle needle out down there, we will. But I'm going to leave all that well alone right now. Alright, well, I got some gas connected to it. I got a meter on the output to see if it makes voltage. I've also turned the speed down a little bit, taken tension off the governor spring just so it doesn't try to over rev on me. I don't know where it's set at, so I always like to back the governors down a little bit so they don't start up and go right to rated. So yeah, we don't have any fuel in the sediment bowl yet. I haven't even tried to start it, so bone dry. So we're all gonna see how long this takes. Unfortunately, there's no priming lever on this fuel pump on this thing, so you know, pretty much it's crank, crank, crank until the pump sucks the prime and fills the carburetor. I could probably prime the carburetor just to get it to run, but we won't do that. We'll see if it'll draw fuel on its own just with cranking. Turn the meter on. Got a little choke knob here. We'll leave the choke off until it gets fuel. Alrighty. Oh, there's the fuel. Alright. Alright, the sediment bowl filled up. It should take off at this point. What do we got here? Give it some choke. discharge here. I don't see any sparking at the brushes. Seems pretty quiet. Looks like we got a little leak around the cinnamon bowl. Not all that surprising. Let's shut it down here. Yeah, that well, the meter first off doesn't really return to zero. So, but it was definitely reading farther than the discharge. The battery was at 12.6 with it running. Let's see what it is now with it stopped. Yeah, 12.6. Okay, well, it didn't really tell me anything, did it? I guess we'll gonna have to get an amp meter out and see what's actually going on here. Alright, stand by. That was a good first run though. A little smoky on the startup, but I did put oil down the cylinders. So, alright. Alright, well I started it back up. Still registering a discharge. But now, I confirmed this with both of my meters. Now it's charging. I don't know, I think that amp meter may be hooked up backwards, because I'm definitely charging. Very strange. Pretty good, it's not missing a whole lot. All this junk that flew out of the muffler. Yeah, really not running too bad at all, actually. I'm gonna let it run for a while, get the oil warmed up. I mean, the pan's cold. It's only been running for 5 minutes though. Hear it kind of ramping up and down a little bit. Yeah. Not too bad. We'll come back when we get the load bank hooked up. Okay, well we're pretty thoroughly warmed up now. I got the load bank connected. We're going to start her up and see what kind of performance we can get out of it. Remember, this is rated at 3,500 watts at 115 volt AC. So that's nameplate 30 amps. No load speed should be about 61.5 to 62 hertz. A little bit more no load speed might be acceptable for this old unit, but I like to keep them as close to 60 as possible. And I don't want to see frequency drop below 59 hertz. So again, this thing is built 1954, so we're gonna go easy on it. If the performance is less than stellar, we won't be surprised. So, start her up. I just gotta put the battery on. vacuum. Clear out for a minute. It seems like it's starting to miss more often. I wonder if that little piece of metal fuel line had some rust particulate in it that is now ended up in the carburetor. It's starting to smooth out now. Turn the meter on. Around between 61.8 and 52 hertz. Again, it's kind of missing and sputtering. 129 volt. I don't put too much stock in the meters on the load bank. They've been banged around enough. Don't know how accurate they are. And move a little closer in here. Can we see the amp meter over by the generator? With the fan, just the fan, we're drawing 0.6 amps, almost an amp. Put a little bit of 2.6 amps, 4.7, let's double that, 8.6 amps. We're down to 123 and 60.4, 60.5. Bouncing around. Not much. So let's switch these out. 8.9 amps. 12.6 amps, and we're bouncing 60 hertz. 120 volt. Put another 16 amps, 59.7, 119. Alright, so we're a little over 50% load right now. Starting to work. Pretty much right bouncing around 60 hertz. 59.8, 59.9. So we got about 2,000 watts according to the load, the heating element. Let's swap these out. Still 16.7. Let's bring it up and get a little bit more. 20 amps. And we drop 58.4. Yeah, you don't like that. 115. It may improve with just simple run time. Get the rings broken back in. It'll probably increase the sensitivity of the governor a little bit. now. 23 amps, 110 volt. Oh yeah, she's falling hard. Alright. 20 amps. Take a walk around the set. Still got almost 25 pounds of oil pressure. I don't see any arcing at the brushes, that's a good sign. All kinds of crap flying out of that muffler now. I'm getting hit with it in my face. Jeez. Man. Well, I'm tempted to take it right up to 30 amps, but I don't know. I think it needs a little bit more TLC before we really go for broke. Uh, 23 amps, 24, 25 amps, but she's falling bad. 55 hertz. Yeah. It won't be too mean to it. At 16 amps, 60 hertz and 120 volts. Load is, yeah, see, no load's a little high now. Yeah, it's bouncing around. Sounds a little noisy to me. Alright. Let it cool down for a little bit and shut it down. The load bank cool off a little bit. Of course, that's, you know, not even half of what this load bank is capable of putting on this thing. 10,000 watt load bank, so. Well, I hope you enjoyed the video. Thanks for watching.